Dear listeners, so happy to have you with us. No one doubts the success of digitalization anymore. Pessimism has long since resigned. This is also evident in the building sector. Here we have the interesting topic of BIM. Our expert is going to explain exactly what this means in a moment. Building information modeling. And during our interview, we'll focus on the sub-area building information modeling in the electrotechnical trade. We've been able to obtain the very best expert on this subject, Christian Frey. Christian Frey is the Vice President Industrial Affairs at Siemens Smart Infrastructure, and he also serves in this capacity at Siemens on the Strategic Advisory Council of buildingSMART International. By the way, behind Mr. Frey you can see Building X. You may now be asking yourself the question, what is that anyway? Building X is an AI-based suite for climate-neutral buildings from Siemens. It's openly scalable on a modular basis and demonstrates very impressively the contribution that digitalization can already make to climate-neutral buildings today. By the way, in our 6th issue of Building and Automation this year we have a very detailed technical article on this topic. But now on to our interview. A warm welcome, Mr. Frey. I'm glad to have you with us. And I'll get right to our first question. Mr. Frey, as representative of Siemens AG, you are a member of the Strategic Advisory Council of buildingSMART International. What do you deal with at buildingSMART International?
buildingSMART is an international industry institution dedicated to the digital transformation of the building industry. The focus is on establishing the Building Information Modeling Work Method, or BIM for short. Together we want to develop and introduce open international standards and solutions for structural infrastructure and buildings. So far, a lot has been done for the design and construction phase. My goal is now to use the data obtained in this process to optimize the operating phase, which after all accounts for 80% of the building's lifecycle costs. That's what I'm working on.
Yes, very interesting. Can you explain to our viewers what BIM is? How do you define it?
BIM is a work method for the network digital planning and construction of buildings. The building is first created here as a virtual model in various levels of detail. Relevant data is thus always directly and continuously available in up-to-date form for all parties involved. DIN ISO 19650 provides a detailed description of information management over the entire life cycle of a building in order to establish a common language that will make construction engineering more efficient. Conflicts can thus be easily resolved with the help of software by means of a simple mouse click as early as the planning phase. And beyond the 3D model, there are also 4D and 5D, which then also enables time and cost calculations, which in turn increases the productivity of the planning process in terms of financial expenditure, but also deadlines and quality. Further dimensions, which then also incorporate dynamic sensor data, are used to optimize the operating phase in terms of energy efficiency as well as the CO2 footprint, but also condition monitoring with regard to maintenance and repairs. We then also talk about 6D or even 7D BIM, and that's what we want to achieve at Siemens.
That sounds very interesting. However, some might say, we have a great solution, but where is the problem? Therefore, allow me to ask you a somewhat provocative question. Why does the industry need BIM at all?
Well, the BIM-oriented work method promises numerous advantages. On the one hand, the quality of the data and thus of the work is improved. Since everyone has access to the common database, which is constantly being synchronized, this avoids multiple entries by the respective trade planners and optimizes workflows, thereby increasing productivity and improving the quality of planning and execution.
Wodurch die Produktivität steigt und sich die Planungs- und Ausführungsqualität verbessert.
In short, the exchange of information between those involved in planning becomes more efficient, and this throughout the entire life cycle of a building. An important prerequisite for this is Open BIM, which we are also advancing with buildingSMART.
Now you are handing me the next question almost on a silver platter. So, what is Open BIM?
Well, Open BIM is a concept for the open data exchange of building models, regardless of which software solution the project participants are using. Previously, the focus of the BIM process was on the design and construction phase. But as mentioned before, about 80% of a building's total lifecycle costs are incurred in the operating phase. This means, early participation, already in the design phase, is crucial to ensure that functionalities and products are properly defined and dimensioned, so that later efficient and sustainable operation can be ensured in accordance with user requirements. The prerequisite for this is the standardized transfer of information to operations while guaranteeing interoperability, which we ensure with Open BIM. The most important exchange format in the Open BIM process is the IFC format. IFC stands for Industry Foundation Classes. IFC has been developed by buildingSMART International and leading software manufacturers as an open exchange format for building data modeling. IFC thus enables the software-independent exchange of information from different trades over the entire lifecycle of a building.
I can see that a lot of heart and soul has gone into it. What have you already achieved? How widespread is BIM in the industry?
Okay, I'll have to elaborate a bit. Up to now, the focus, also of buildingSMART, was strongly on the areas of building construction, infrastructure buildings, tunnels and bridges, and here in particular in the planning and construction phase, mainly of complex structures such as airports, railroad lines, hospitals, and so on. In many countries, there are already legal requirements for this in place, especially for the implementation of public sector projects, in order to keep an eye on the cost and time schedules. In Germany, for example, the Digital Planning and Construction Step-by-Step Plan was launched by the former Federal Ministry of Digital Affairs and Transport and Digital Infrastructure in late 2015. This plan already included a description of how BIM was to be introduced, which is the standard today. However, the pressure to use BIM is also increasingly coming from the private sector, because no one will be able to afford projects that run out of time and money due to a lack of coordination, and there are plenty of examples. The aforementioned DIN ISO 19650 standard is an international standard that defines how information must be managed throughout the life cycle of a structure using BIM. After all, planning, construction and operation must always be viewed as one overall task. If you don't plan the operation, you can't plan an efficiently functioning building. This standard will therefore establish itself as a common language that will quickly spread throughout the industry to eliminate poor or missing information management. Some trades, for example heating, ventilation and air conditioning technology, building management systems, and also building automation, are already well advanced in this respect. In other industries, for example electrical engineering, it still has to be proven that BIM is also relevant for them. In the future, a building will have to demonstrate that it produces electrical energy sustainably, distributes it efficiently, and also stores it temporarily.
Yes, that's exciting. After all, Your company, Siemens, originally comes from the electrical engineering sector. So, what significance does BIM have for Siemens as a company?
Well, as a technology and market leader in smart infrastructure, Siemens is naturally involved in shaping the digital transformation. So digital construction, and with it BIM, is a crucial part of this transformation. That's why we are relying on BIM and digital building twins even for the redesign of the historic Siemensstadt in Berlin, in order to also design the new Siemensstadt 2.0 neighborhood intelligently and sustainably. But the topic of decarbonization is also becoming increasingly important to Siemens regarding its corporate and social responsibility. Our chairman of the supervisory board, Jim Hagman-Snabe, advocates seeing uniform standards for BIM as a means and an opportunity to further drive sustainability in the infrastructure market, and that's exactly what we are working on at BSI. By the way, our new smart infrastructure headquarters here in Zug, Switzerland, was built using the BIM planning method.
That's exciting. Well, as you said, energy transition, sustainability. These are the hot topics of our time. What influence does BIM explicitly have on decarbonization?
A major influence, because buildings currently contribute to about 40% of CO2 emissions. And this must be reduced in the future by all means. Much has already been achieved through measures such as thermal insulation, but the eco-balances of insulation materials vary widely. The analysis of thermal energy in building planning is already standard and thermal simulation software tools have been available for years. However, great potential for more efficient buildings lies in the area of controlling functions that consume electrical energy. And there are quite a few in modern buildings, for example automatic blinds, lighting concepts, or air conditioning. In short, without electricity, nothing works in smart buildings anymore. And what makes sustainable control even more complex, electricity is not only consumed, but now it is even being generated by the building itself. In order to simulate building functions even before construction and to transparently record and control the overall energy consumption during the operating phase, must all relevant processes be brought together in a building management system? Ideally, the digital model required for this is already created in advance using the BIM data, and is subsequently used in operation as a digital twin. And this also especially for the complete electrical power strand of a building. So our vision is that the focus in buildings from now on will be more on sustainable control and electrical engineering. Buildings must be able to think along and think ahead. In this way, they learn from previous experiences and adapt to the users. This also includes the inclusion and processing of meteorological data and other environmental data, which are indeed available. People also like to talk about artificial intelligence.
That's a broad field, very exciting. What is Siemens contributing to making these versions a reality?
Siemens Smart Infrastructure has expertise in building automation and also building electrification. We are breaking away from rigid passive structures and are developing a new understanding of building management systems. We offer this expertise, among others, to BSI as a founding member of the new Sustainability and Energy Management Room. The goal of this working group is to develop an open BIM standard for electrical engineering as well. This is because it does not yet exist. And, of course, it's a top priority for us to work on expanding our own BIM offering accordingly in the future. This also includes supporting and advising our customers to make them fit for BIM.
Thank you very much Mr. Frey for your interesting explanations. I really enjoyed it. I think it's a really interesting topic that you're covering and promoting. Mr. Frey, allow me to ask you one last follow-up question. Will you also be exhibiting this range at the upcoming Light Plus Building Trade Fair?
Yes. At the world's leading trade fair for lighting and building management systems, we will show how the pressing challenges of urbanization and climate change can be met by networking energy systems, buildings, and industries, because smart infrastructure is sustainable infrastructure.
Denn smart infrastructure is sustainable infrastructure.
So, visit us at the trade fair and we'll talk about it. Thank you in advance for your interest.
Yes, thank you. I will definitely do it. I'll stop by. Mr. Frey, thank you very much for the interesting interview. I really wish you every success with this interesting technology, and that you bring it forward with the enthusiasm you have shown here. Thank you, Mr. Frey.
My pleasure, thank you.